It's 7 degrees east. That's the first part solved. The next question is, what is the Great Circle track at 11 east? Draw it in. 11 east is 4 degrees east of 007 east, and it is 4 degrees west of 15 east. Therefore, it must be the mid-meridian, as it's halfway between the meridians C and D. So if the track is 300 at the start and 295 at the end, what will it be exactly halfway? 297.5 degrees true. Now one for you. The initial Great Circle track from H at 40 south, 170 west, to G at 45 south, 174 east, is 250 degrees true. What is the initial Great Circle track from G to H? What's the first thing you have to do? Are we in the northern or southern hemisphere? We are in the southern hemisphere, so draw in some lines converging southwards. The question says that the track leaves H on 250 degrees true to meet G. So which one is G and which one is H? H must be on the right and come across to meet G on the left. Now put in the latitudes and longitudes and check it out for sense. H is at 40 south. G is at 45 south. Does this look right on the diagram? Yes, it does. The diagram shows G to the south of H. H is at 170 west and G is at 174 east. However, on our diagram, why is west out to the right of east? That's not how we normally see it. The reason, of course, is that we are looking at a situation based on either side of the Greenwich anti-meridian, not the meridian. Our two longitudes are either side of the 180 degrees east or 180 degrees west, which is the same thing. Take the shorter departure between the two longitudes, in this case, the one crossing the Greenwich anti-meridian. In other words, the change of longitude is 16 degrees, not 344. Now substitute in what you know. So, how much has the Great Circle track angle changed between G and H? What's the formula? It's the convergency formula. Convergency equals change in longitude times the sine of the mean latitude. Now put in the figures you know. We know the change of longitude. It's 16 degrees. We know the mean latitude. It's 42.5 south. Now use a calculator to work out the convergency. You find that the convergency is 10.8 degrees. So the Great Circle track angle has changed by about 10 degrees. Which way? Has it become about 240 or about 260? How can we find out? Use the DIID rule. We are flying westwards in the southern hemisphere. The track angle must be increasing. Look at the diagram for confirmation. The left-hand meridian is further anti-clockwise than the right-hand one. This means that when you measure a track angle clockwise from it, you will get a greater angle. So the westerly track angle at G is 260.8. What does that make the easterly track angle at G, the initial great circle track from G to H? 080.8. You apply 180 degrees of difference for a reciprocal track. It's just the opposite direction to 260.8 degrees. Alternatively, you could have used the method of paralleling the meridian. Here is the paralleled meridian. This is the corresponding angle of 250 degrees true. So what will be the reciprocal track from the parallel construction line be? 070 degrees true. However, this is from the paralleled construction line. We now have to add the convergency in order to measure from local true north. So the initial great circle track from G to H is 080.8. Let's summarize what we've covered. Convergency, or Earth convergence, results from the fact that, except at the equator, meridians are not parallel to each other. Convergency is defined as the angle of inclination between two selected meridians measured at a given latitude. Convergency is also the change in great circle track direction between 2 points. The formula to calculate convergency is convergency equals change in longitude times the sine of the mean latitude. For questions involving return initial great circle tracks, work out what the final track will be and then reciprocate it. Alternatively, use the method of paralleling the meridian. For other types of question, write down the formula and substitute in what you know. The answer will usually drop out.